Okay, so welcome back to session 2 and this is video 4. Okay, now children, we are going to see application of HCF. See, whenever you want to make application of anything, you have to view at that thing from different angles. So here, if you are thinking of making application of HCF, you will have to look at it from different angles. Well, one angle from which you are going to visualize HCF is 40 degree. Angle of 40 degree. I dedicate this 40 degree to my mother who left for heavenly abode at the age of 40 in 1980. That time I was just 10 years old. No marks for guessing correct age of mine. So what could be my age now? Alright. Now see, life without mother is very different and difficult. Right? So respect your parents, love them and listen to them. Fine. In the previous video, you have already seen this. X is equal to A into B. Y is equal to A into C. If we come across this type of situation where we have two equations, well, here B and C are co-primes, and this is the highest factor which divides X and Y. So here you can say A is HCF of X and Y. This is looking at HCF. This concept is looking at HCF from angle 40 degree. When you look at HCF from angle 40 degree, you can visualize this concept. Which concept? X is equal to A into B. Another number Y, it is A into B, where A is highest factor which divides them and B and C are co-primes. We have seen this in previous video. Right? Okay. Now in the next problem or sum, we are going to use the application of HCF. Let's see. Okay. Let's make application of HCF here. But before we solve these two sums, we need to know what is Euclid's algorithm. Well, I'm going to discuss about Euclid's algorithm in the next video in detail. But here we'll see briefly. Look at one example. 20 divided by 3. 3 6 are 18. 20 minus 18 is 2. This, as you know, is called dividend. This is quotient. This one is the remainder. And this one is divisor. If you observe, every time you will find this result. 20, which is dividend, is equal to 3 divisor into quotient. What is 3 into 6? 18. What is 18 plus 2? 20. That is dividend. Dividend 20 is equal to divisor 3 into quotient 6 plus remainder 2. Are you getting me? 20 is equal to 3 into 6 plus 2. No matter whatever division may be, this dividend will be always equal to divisor into quotient plus remainder. So here I can say dividend is equal to divisor into quotient plus remainder. Are you getting me? This was for the first time given by Euclid. So it came to be known as Euclid's algorithm. I am going to discuss about that in detail in the next video. But this will be useful to us here. Please pay attention. Right. Let's see the first one. Find the greatest number which divides 80 and 68, leaving remainder 8 in each case. Find the greatest number. Do you know which is the greatest number without finding? No. If it is not known, that means it's unknown. If it is unknown, we can say x, y, a, b, whatever. So let's say that greatest number is x. The greatest number which we have to find is x. So x is the greatest number when it divides 80 and 64, leaves the remainder 8. Can we put this in the form of symbol, or symbolically can we write down this statement? Yes. Let's see. The first number is 80, correct? The second number is 68. Let that greatest number be x. Children, here I write that statement. Let x be the greatest number. X be the greatest number which, I'm not going to write here, which divides 80 and 68, leaving remainder 8 in each case. Are you getting me? Let x be the greatest number which divides 80 and 68, leaving remainder 8 in each case. So see, when you divide 80 by x, the remainder is 8. When you divide 68 by x, the remainder is 8. You know about the remainder, but you don't know about the quotient. So I'll say here the quotient is A, and here the quotient is B. See, this statement is put in symbolic form. Are you getting me? Find the greatest number. Let that greatest number be x. So when you divide 80 by that greatest number and 68 by greatest number, the remainder is 8 in each case. The quotient in the first case is A, the quotient in the second case is B. Let's use Euclid's algorithm, which says dividend. What is dividend? 80. Now, 80 is equal to, please write divisor first, x into quotient A plus remainder. Use Euclid's division rule here as well. Dividend 68 is equal to x into B plus 8. Correct? I'm going to call this result that we got as 1. Be careful now. I'm going to write directly. You are studying in standard 10, not small key. I'm going to take this plus 8 on other side. So what is 80 minus 8? Good. 72 is equal to x into A. 68 minus 8, that will give me 60. That is equal to x into B. And I got this by 1. From 1 you got that. Alright. And this result I am going to call it as 2. The new result what I got. And if you look at it, you are watching at HCF from angle 40 degree. Do you remember? Yes. So, what is this? Correct. It is HCF. Thus, X is HCF of 72 and 60. Are you getting me? Now you find out. Find out the HCF by any method. Okay? I'm just erasing this part to find the HCF. Let's find out prime factors of 72 and then find out the prime factors of 60. 2 36s are, 2 18s are, 2 9s are, 3 3s are, 3 1s are. 2 30s are, 2 15s are, 3 5s are, 5 1s are. 72 is equal to 2 multiplied with itself 3 times, 2 cube. 3 multiplied with itself 2 times, 3 square. For 60, 2 is multiplied with itself 2 times, 3 is multiplied, 3 appears 1. So 3 raised to 1 you may write, 5 appears 1. So you may write 5 raised to 1. Better you write 1, though it is not necessary. Thus, HCF of 72 and 60 is equal to, recall the prime factorization method, power with same base 2. Which power is having lower index? That is lower index we see for HCF. Is it 3 or 2? Smaller index 2. So 2 square. Well, here this is also common. Power with base 3. Which is power with smaller index? Is it 1? Is it 1 or 2? 1. So 3 raised to 1. Well, power with base 5 is present in the second number 60, but it's not so in first number 72. So it's not common. So this is equal to, what is 2 square? 4 into 3. And what is 4 3s are? 12. Correct? So what is HCF? 12. And what is that? That is X. HCF of this two number is X. So you may write down i.e. X is equal to 12. That means X is equal to 12. And what is X? The greatest number which divides 80 and 68, leaving remainder 8 in each case. Did you understand? So what is the answer here? What is that greatest number? 12, which divides 80 and 68, leaving the remainder 8 in each case. Clear to you? So this is how you, same way children, you represent the solution. Even you can write that division, doesn't matter. Are you getting my point? Fine. Alright. Now, we are going to see justification. To have greater understanding of this sum, let's go for justification. What is the first number? 80. What is the second number? 68. What is the greatest number that divides them? 12. 12. The answer that we got. Now what is this? 12 6 are 72. 80 minus 72 is 80. 12 5s are 60. And 68 minus 60 is 80. So got my point? Got my point? See? 80 and 68 is divided by greatest number 12, leaving remainder 8 in each case. But you don't have to give justification. This is just for you to understand this statement in a better way. Okay? Can we do the next now? Fine. Solution of 2. See, I'm going to present this very nicely. Alright, this time, so that you also know exactly how to write in the answer sheet. Find the largest number, that's the question, that divides 49 and 68, leaving remainders 1 and 4 respectively. This time the remainder is not same. The remainders are different. When you divide 49 by that greatest number, the remainder is 4. When you divide 68 by that greatest number, the remainder is 4. So remainders are different. Are you getting me? Well, it's going to be very easy, children. Fine. Let the largest number that divides, let x be the largest number. Let x be the largest number. Then I'm not going to write. You can write from here. Number that divides. Please write complete statement. Don't write like me. That divides 49 and 68, leaving remainder 1 and 4 respectively. Got it? Represent this statement in symbolic form. That is dividing 49 and then dividing 68 by x. The quotient we do not know. Let me say Q1 this time. Let me say Q2 this time. In the first one, the quotient is Q1, Q2. You can use variety. Well, the remainder in the first case is 1. Here, the remainder in the second case is 4. you can represent this using Euclid's lemma. And what is that? 49. Now 49 is equal to x into q1 plus 1, and 68 is equal to x into q2 plus 4. Call it result number 1. This is one result we got from this. From this, take one another side. So 49 minus 1, what will be that? 48. Take this 4 on other side. 68 minus 4, what? 64. Correct? So by one, it follows that, बोलिए 49 minus 1, 48 is equal to x into q1. 49 minus 1 is 48 is equal to x into q1. 68 minus 4, that will be 64, is equal to x into q2. 64 is equal to x into q2. Call this result 2. You got new result now. But this is viewing HCF from angle 40 degree. Got it? So what you can say from here? X is HCF. Thus x is equal to HCF of 48 and 64. 48 and 64. 8 6 are 8 8 are 60. That you find out now, children. That HCF you find out. You know, I'm writing directly. What is the HCF of 48 and 64? We get 60. And what is x? Okay, what is x? The largest number which divides 49 and 68, leaving remainder 1 and 4. So you may write the answer. 16 is the largest number. 16 is the largest number which divides 49 and 68, leaving remainders 1 and 4 respectively. Children, dot 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 dot. It is only for me and not for you. You have to write completely. Got that? Okay. All right. Let's see another application of HCF. We are going to view HCF from another angle. This time I am going to call this angle of 77 degree to dedicate my daddy who passed away in 2003 at the age of 77. Once again, this is not in mathematics. Viewing HCF from angle 77. Now what is this? Let's see. Observe and understand. Let's play a game. We need some marbles to play this game. And where are the marbles? Well, I'll just represent them on the board. Here are red marbles. They are 8 in number. Here we have 12 marbles which are blue. I hope you can detect the color, red and blue. 8 marbles are red in color, 12 marbles are blue in color. Correct? Now we need to see the rules of the games. In this game, we are going to form groups. What we are going to do? Formation of groups. And to form the groups, we have to fulfill certain conditions. First condition is condition 1. Both kind of marbles should be there in each group and in equal numbers. And second condition of the game is no marble or marbles, all right, should be left out. Should be left out at the end of group formation. Once again, what is the game? With the help of these two kinds of marbles, I am going to form the group. And while forming the group, these two conditions are to be kept in mind. Both or every group should contain red as well as blue marbles. And in each group, the number of marbles should be same. After distribution of marbles in different groups, not a single marble should be left. Is that clear to you? Did you understand the rules of the game? So let's start. Before starting, let's think a bit. How many groups can we form? Can we form one group? Yes. Take one group, put all the marbles, blue as well as red. So one group is formed. But there is no second group there for comparing. Correct? Okay. Can we form two groups? Yeah, we can form two groups because there are 8 marbles here. Less number of marbles are 8. More number of marbles are 12. So maximum we can form 8 groups. If we form one group, we can put all 8 marbles there. If I form 2 groups, I can put 4 marbles there. If I form 3 groups, I can put 3, 2, 2, 2. The distribution would be difficult if I form 3 groups. But I can form 3 groups because I can put some marbles there. 4 groups, 5 groups, 6 groups, 7 groups, 8 groups. I cannot form 9 groups because there are only 8 marbles. Here I can go till 12 groups because there are 12 marbles. But then I am going to merge both the kinds of marbles, both the colored marbles, and then form the group. So maximum I can form 8 groups. Okay. Let's see. One group. Only one group. Okay. And in that, see, all 8 marbles I am getting. 1, 2, 3, 4, 5, 6, 7, 8. And all blue marbles I am getting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is formation of one group. Okay. Now you can also form 2 groups. So when you form 2 groups, what happens? This is group 1 and group 2. In group 1, okay, 2 groups I have formed and I have got 8 red marbles. So in each group, how many marbles can I keep? Correct, 4. So this 4 marbles I am placing in this group. Sorry. And 4 marbles in this group. How many marbles we have of blue color? 12. So how many marbles can I keep in each group if there are 2 groups? 6, correct. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, not a single marble is left. See, 6 and 6, 12, 4 and 4, 8. Not a single marble is left. So here, this group formation satisfies the condition. Here you can compare. How many marbles in all? 4 and 6, 10. 4 and 6, 10. So in each group there are 10 marbles. In each group there are 4 marbles of red, 6 marbles each of blue. So conditions are satisfied. And not a single, all these 8 marbles are occupied. 8 marbles are utilized. Not a single marble is left after the formation of groups. Did you get that? Now let's see. We'll try to form 3 groups and what happens? 3 groups. 1, 2, and 3. Now you have to be careful. I'm putting 1 here, 1. The next marble I'm putting here. The 4th one I'm putting here. 5th one here. 6th one here. And then 2 marbles of red are left. Now I should not go for putting these blue marbles into these 3 groups because the condition of the game, the rule of the game is not fulfilled. You can put 2 marbles. When you form 3 groups, you can put 2 marbles of each red color, but 2 marbles are left out. No marble should be left out anyway. Can you form 1 group? Yes. Can you form 2 groups? Yes, which satisfies both these conditions. But when you form 1 group, there is no another group where you can compare to show that number of marbles in each group is same. Correct? Here 2 groups are there and it can be formed, it satisfies the condition. If you form 3 groups, you can't because the marbles are left. Alright, we'll move further. Alright, now we'll form 4 groups. Let's see. I'll write here. You could form 1 group, you could form 2 groups. 3 you couldn't. 3 groups you couldn't. Correct? Okay. Now we'll see formation of O groups. Alright? Yeah. 1, 2, 3 and 4. Let me write here. G1, group 1, group 2, group 3, group 4. Correct? Now I've got 4 groups and I have to allot red marbles in each group. What will be the allocation? How can you allot? What would be the allotment? Let's see. 1 red, first red here, second red here, third red in the third group, fourth red. Again, fifth red here, sixth in the second group, seventh in the eighth group, in the third group, and eighth in the fourth group. So all 8 marbles are placed in 4 different types of groups. Correct? And not a single marble is left. Now it's time to allocate the blue marbles, distribute the blue marbles into 4 groups. First marble, second marble, third marble, fourth marble, fifth marble, sixth marble, seventh blue marble, eighth blue marble, ninth blue marble, 10th blue marble, 11th blue marble, and 12th. I made mistake. Yeah, I wrote here double. Yeah, see the allocation. I made mistake while distributing the marbles. So you can see 3 blue marbles of each are placed in 4 different groups. And not a single blue marble is left out. So again, you can form 4 groups. You can form 4 groups. Correct? Which satisfies the rules of the game. Let's see if we can form 5 groups. Group number 1, group number 2, group number 3, group number 4, and group number 5. Well, out of 8 marbles, 5 marbles will go in the 5 groups. 1, 2, 3, 4, 5. Now if you try to allocate the remaining one, allot the remaining one, then only 3 marbles. It will go in only 3 groups. It will not go in the other groups. The number of each colored marble should be same. So if I put 1 marble here, here and here, well, all 8 marbles are allotted already. They are distributed. But now, the number of red marbles in all 5 groups is not the same. 2, 2, 2, 1, 1. 8 marbles are over. So according to the rule, you need number of marbles in each group the same. So 3 marbles would be left out after allotting 1 marble each in 1 group. So again, I should not go for the distribution. There is no need to do that because the conditions of the game are not satisfied. So if you try to form 5 groups, it's not possible. It does not satisfy. Let's form 6 groups. Let's form 6 groups. All right. Third, fourth, fifth, and sixth. Group 1, Group 2, Group 3, Group 4, Group 5, Group 6. Children, first marble, second marble, third marble, fourth marble, fifth marble, and sixth marble. 2 marbles are left, and 2 marbles cannot be allotted in the 6 groups. 2 marbles cannot be distributed among 6 groups, right? So again the condition is not satisfied. So if you try to form 6 groups, you can't. Clear to you? Alright. Bolo, can you imagine if you can form 7 groups? No. Because when you form 7 groups, you can allot 1 red marble in each group and 1 marble would be left. So this condition is not satisfied. I hope you understood that. Can you allot 8 groups? I'm sorry. Can you form 8 groups? Let's see. 1, 2, 3, 4, 5, 6, 7, and 8. This is group number 8. This is group number 1. Okay, I'm just saving time, so I'm not writing or labeling every group. Chart. Yes, 1, 2, 3, 4, 5, 6, 7, and 8. All red marbles are allotted there. Now I'll allot the blue marbles. Well, here color change is there, but I hope you'll understand. First, second, third, fourth, fifth, sixth, seventh, eighth. How many marbles are left? 4 blue marbles would be left, and you cannot distribute them among 8 groups. So again, this time the blue marbles do not satisfy the rules of the game. So again, formation of 7 groups, as I said, can't, and 8 groups also you can't. So the possible ways to form the groups which satisfies these 2 conditions are: 1, you can form 1 group, or you can form 2 groups, or you can form 4 groups. But how to know this? Do you have to do this practical work? No, children. See, what you do if you want to know this. What is the first number? 8. Write all its prime, all factors of 8. 1, 2, 4, and 8. Then next number is 12. Write all factors of 12. 1, 2, 3, 4, 6, and 12. Find out the common factors. Common factors. 1, 2, and 4. Are you getting something? Right. The common factors of both the numbers is actually the number of groups that you can form, satisfying these 2 conditions. And if I say, I want to form maximum number of groups, I want to form, in this game, I want to form maximum number of groups. So how many groups can I form? That is HCF. That is HCF. HCF is 4. There are 3 possibilities of formation of group. Form 1 group, or form 2 groups, or form 4 groups. But if you are asked to find or form maximum number of groups, then how many is that? 4. And what is 4? 4 is HCF of 8 and 12. So this is visualizing or looking at HCF from angle 77. I'll recall this. यहाँ हमें क्या application करना है? Looking at angle from measure 77 degree. Is that clear to you? Let's see the application of that 77 degree angle. Okay. A sweet seller has 420 Kaju burfis and 130 Badam burfis. She wants to stack them. What is stacking? Making pile like this. Alright. That is called stack. That is called stack. You know the burfis, what shape they are. It may be cuboidal, cubical, or cylindrical. Alright. So placing burfi one over the other, that is stacking. Alright. So she stacks them in such a way that each stack has the same number. In each stack, the number of burpees should be same. Kaju burpee as well as badam burpees. B for badam, badam burpees. She has to stack. The number of burpees in each stack should remain the same. That is how you have to arrange them, right? Not only that, number of burpees in each stack has to be same, and they take up the least area of the tray. Well, these stacks are kept in a tray. The area of the tray that is occupied should be minimum. It should be least. Be careful, huh? Try to understand. It's like the blue marble and the red marble game. It's like that only. Instead of blue marble and red marble, we have Kaju burpees and badam burpees. We have to stack them. That means we have to group them. Are you getting me? So, what are the possible ways of grouping them? What are the possible ways of stacking them? That will be the common factors of 420 and 130. Let's try to understand first. Alright, 420, the factors. 2 2s are 1s are 2, 1 0 5s are 3, 3s are 5s are 5, 7s are and 7 1s are. So all factors, pairs of factors, 1 into 420, then 2, then 3, double 2, 4, 5 is there, 6, 2 3s are is there, 7, as I told you, take the breath. Okay, 2 into what? So hide 2, the product of these 4 primes, that is 5 2s are 10 and 21, 2 10. 3, hide 3, 5 2s are 10 and 14, 140. 4, double 2 you hide. 7 5s are 35 and 35 3s are 105. Hide 5. 4 3s are 12 and 12 7s are 84. Hide 6. 5 2s are 10 and 77. 5 2s are 10 and 60. There are more. Difficult job. Chalo. After 7 comes 8. Triple 2 hai 9. 9. Double 3 hai 9. 10. 5 and 2 hai. So 10 is the next factor. So hide 2 and 5. So what is left? 2, 3 and 7. 2 3s are 6, 6 7s are 42. Chaliye, 11. 11 is prime. It's not existing here as a prime factor of 420. 12. 12 has 3 factors. Double 2 and 1 3. Here 12. So that is 12. 12 into 35. Alright. The next is 13. 13 is prime itself. Nahi hai. So it's not a factor of 420. Right? 14. Yeah. 7 and 2 exist. Look, 7 and 2. That is 14 into the remaining. 5 2s are 10. 10 3s are 30. After 14 is 15. Are you having 15? 5 3s are? Yes, 5 and 3. So 15 is a factor and 4 7s are 28. Chalo, 16. Well, in 16 you have 4 2s. Here only 2 2s are there. So it's not a factor. 17, prime, not there. 18, double 3 and 2. No, here double 3 are not there. 19, it's prime. Do we have prime number? No. 20, double 2 and 5. Yes, double 2, 4 into 5, 10. 20. So that is 20. And what is left? Into 21. After that is 21, 20. After 20 is 21. And we already have it. Bapre, we got so many factors of 420. 1, 2, 3. Start writing. 4, 5, 6, 7. Then 10. 10, 12, 14, 15, 20, 21. I go up now. 28, 30, 35, 42, then 60, 70, 84, 105, 140, 210, and 420. Right? Same way, I'll find out the factors of 130. That would be a little bit easier. 130, because lesser number of prime factors we are going to have. 2 6 are 5 are. Yeah, 5 1s are 13s are. So only 3 prime factors. So pairs of factors also would be less. 1 is a factor of all number. 1 has to be multiplied with number itself. So you got the first pair. After 1 comes 2. Yes, it's present. After 2 comes 3. No, it doesn't exist as prime factor. Then 4. Double 2 we need. Only 1 2 is there. So it's not a factor. 5. Yes, it is. 6. 2 and 3. 2 is there but 3 is not there. 7. Prime factor. नहीं है. 8. Triple 2. नहीं है. एक ही है. 9. Double 3. एक भी नहीं है. 10. 2 and 5. It is there. Well, I have to take breath. Correct? चलिए. 2 into what? 16, 13 pi. If you hide 2, 13 pi is 65. Hide pi, 13 2s are 26. Hide 10, 10, 13s are 10 into 13. Now you proceed further. You have taken a breath. Now you take, after 10 is 11. Prime, nahin, 12. Double 2 or 3. Double 2 and 3. No, they are not there. Then 13. Here it is 13. So you have 130. The factors of 130. 1, 2, 5, 10, 13, 26, 65 and 130. Have you got it? Common factors. 1, 2, 5. 10 is not common. Do we have any more common factors? No? Sure? Sure? Yeah, 10. Sorry, yeah? Here is 10. 10 is also a common factor. Correct? So, this common factor indicates what? If you visualize HCF from angle 77 degree, you have 4 options. Make stacks of these 2 types of burpees. In each stack, keep 1 burpee. Or in each stack, you can keep 2 burpees. Or in each stack, you can keep 5 burpees. Or in each stack, you can keep 10 burpees. So you've got 4 choices. There are 4 possibilities of making the, which satisfies the condition. Same number of burpees in each stack, okay, उतना satisfy करता है. लेकिन the area covered or area occupied in the tray has to be minimum. Now try to understand, children, please. Let's say this is the tray. If I put each burpee, in each stack, if I put only 1 burpee, then this is Kaju burpee, Kaju burpee, Kaju burpee. Only 1 burpee I kept in the stack. How many Kaju burpees I'll have to place in the tray? 420. So it will take large area. After that, 130 burpees in this tray I'll have to put. And in every stack only 1 burpee. So it is going to occupy larger area. Fine. So I won't take, it's taking larger area. What happens when we take 2 burpees? The area will be reduced. 420 burpees are now stacks are divided into 210 stacks. The number of stacks will reduce because we are putting burpees one over the other. So now the area has reduced when you put 2 burpees in its stack. Same way here in this tray, in first case, 130 stacks of badam burpees were there. But when you place 2 burpees, it will be reduced to half, 65. So area occupied in the second case is reduced. Well, you got one more choice. 5 burpees in its stack. 1, 2, 3, 4, 5. So how many stacks will be formed? 420 divided by 5. What will be that? 5 8s are and 5 4s are. 84 stacks. In first case, 420 stacks of Kaju burpees. In second case, 210 stacks of Kaju burpees. In third case, only 84 stacks would be there. So area is reduced. Area is reduced. And one more case is there. Well, how many burpees are stacked in this case? 10 in it. So what will be the total number of stacks? 420 divided by 10. So only 42 stacks of Kaju burfis. And how many stacks of badam burfis would be there? Only 13. So in this case, 420 stacks of Kaju burfi, 130 stacks. So total 550 stacks would be kept in this tray. Second, 210. And what is half of this? 65. So plus 275 stacks will be formed when you put 2 burfis in each stack. 84 plus, now this 130 divided by 5, 5 2s and 6 are, so 26 stacks would be formed. So total 110 stacks would be formed. And here 42, 420 divided by 10, because in each stack there are 10 burpees. 130 divided by 10, that will be 13, 5 and 5. Only 55 stacks would be formed. So which option will you choose? Will you choose first, second, third or fourth? In which case, the area occupied by the stacks of burpees is least minimum. Yeah. Only 55 stacks have to be arranged. And in each stack, the number of burpees would be 10. Here, 550 stacks will be have to arrange. And in each stack, there is only one burpee. In this case, 275 stacks of burpees will have to be arranged. And in each stack, there will be 2 burpees. In this case, 110 stacks of burpees will have to be arranged in the tray with 5 burpees in each stack. And in this case, only 55 stacks will have to be arranged with 10 burpees in each stack. So, once again, I am going to read this. This is just an explanation. This is just an understanding. I hope you understood. The highest common factor of this 2 number is 10. And that is the number of burpees that you can take in each stack. Correct? Okay. I'm going to read the statement once again and try to understand. A sweet seller has 420 Kaju burpees and 130 Badam burpees. She wants to stack them in such a way, that each stack has the same number. And they take up the least area. When they are arranged in a tray, they take up the least area of the tray. What is the number that can be placed in each stack? We do not know how many number of burpees we can place in each stack. We are going to call it as X. Let X burpees can be placed in each stack. Now what is X? The highest common factor of 420 and 130. Actually, there are 4 possible ways, correct? Someone will say, sir, 2 ही stack बना लो, minimum area होगा, ये बहुत बड़ा, एक ही stack काजू बर्फी का, एक ही stack बादाम बर्फी का, सिर्फ 2 stack minimum area. But then the second condition is not satisfied. The number of burpees in each stack has to be same. So if you want minimum area, only 2 stacks you can form. I don't know how you can place 420 burpees in one stack. Very difficult. Okay, fine. So now, how will you write the solution? आपको solution कैसे लिखना है? Solution, okay? What is, this is the question. What is the number that can be placed in its stack? Let the number of burpees placed in each stack be X. You know now, thus X is equal to HCF of 420 and 130. Now 420 prime factors 2, okay, 130 So prime factors of 420, 2 is multiplied with itself 2 times, you may write 2 square, 3 appears once, 3 raised to 1, 5 appears once, 5 raised to 1, 7 appears once, 7 raised to 1. Here, 130, 2 raised to 1, 5 raised to 1 and 13 raised to 1. Thus, HCF of 420 and 130 is equal to, well, powers with common base 2. We are finding HCF, so power with lower index. which is lower index, 2 or 1? 1. So you choose this power, 2 raised to 1. Then what's common? Power with base 5. Index is 1, index is 1. Which is lower? Pick any. 1 or 5 raised to 1. So 2 pi's are 10. 2 pi's are 10. Then you may write in each stack 10 burpees can be placed. So the last question of this session today. Let's read the question. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in same number. In each group the number should be same. Of columns, number of columns, same number of columns. What is the maximum number of columns in which they can march? What is the maximum number of columns in which they can march? Children, remember, in case of red and blue marbles, we formed groups. We formed groups. Alright? So, while forming groups, we distributed red marbles and blue marbles. In the sum previous to this, we formed stacks. We formed stacks. And there, the two kinds of burpees, Kaju burpees and Badam burpees, they were distributed in those stacks. Correct? And in this sum, we have to form columns. We have to form columns. And what we have to distribute? Two things. Army contingent and army band. Well, the contingent will have all those weapons, right? Rifles and all that. And band, they will have musical instruments in their hands. Am I right? Did you understand that? So we have two types of army members. One with arms, the other with musical instruments. The one with musical instrument, they are the members of army and they are called army band. And with the weapons in the hand, they are called army contingent. Okay? So, just like red marbles and blue marbles be distributed, yeah, Kaju burpees and Badam burpees be distributed, here we have to distribute army contingent and army band. Here we form groups, here we form stacks, here we are going to form columns. Actually, the meaning of all this is formation of group only. We are forming groups only. Alright. Once again, I'll read the question. An army contingent of 616 members. Army contingent. Kaju burpees were 420 in number. Badam burpees were 130 in number. Red marbles were 8 in number. Blue marbles were 12 in number. We found it here. We found it here. Here, army contingent, they are 616 in number. And army band, they are just 32 in number. So let's find out that here. So we'll get the number of column maximum. Okay. Solution. What is the maximum number of columns in which they can march? Let the maximum number of columns in which they can march be X. Thus, X is equal to HCF of 616 and 32. Let's obtain the prime factors of 616. 2 3s are, 0s are, 8s are. 2 1s are, 5s are, 4s are. 2 7s are, 2 7s are. 7 11s are, and 11 1s are. 32 all 2s. 2 16s are, 2 8s are, 2 4s are, 2 2s are, 2 1s are. Now, if you represent 616 as product of powers 2 cube, 7 raised to 1 and into 11 raised to 1. 32, well, it is multiplied 5 times with itself. So 2 raised to 5. Thus, HCF of 616 and 32 is equal to, power with base 2 is common. The lower index is 3, and here the index is 5. The lower one is 3. So this power is chosen, 2 cube, and that is equal to 2 into 2 into 2. Sometimes children make mistake. 2 multiplied by 3, 6 they write. Okay, 2 multiplied by 3 and 2 cube are different stories. Okay, this is 2 3s are 6. This is 2 into 2 into 2. That is 2 2s are 4 2s are 8. I hope you got that. So answer is, what is that? X. Therefore X is equal to 8. So maximum 8 columns can be formed. Is that clear? You can form different number of columns as well. If you take all common factors of 616 and 32, you can think of all possibilities. But formation of 8 column is the maximum. Correct? Okay.